In this video, we're going to evaluate the integral of 1 over x squared plus 6x plus 7, and the denominator doesn't factor. We do have a rational expression for the integrand, but it doesn't factor. So we're going to look at u substitution. We can complete the square of this trinomial, and if we get something of the form either u squared plus a squared, where u is a function of x and a is a constant, or it could be u squared minus a squared, or it could be the other way around, a squared minus u squared. Again, u is a function of x. And these could be in the denominator or the numerator, and they could have a square root here, this one a square root, this one a square root, and so on. For the first one, this would involve a tangent substitution. If it's in the second way, the second form here, this would involve a secant substitution. And if it's in the form a squared minus u squared, this will involve a sine substitution. There's also one for cosine, but these are the main three. So what I'm going to do, I'm going to complete the square here, be x squared plus 6x, quadratic here. Because the coefficient of this square term is a 1, to complete the square here, I simply take half of the 6, the coefficient of the x, which is 6, is 3, square it, I get 9. X squared plus 6x plus 9, that's a perfect square. That factors into x plus 3, quantity squared. The only problem is this is not the same expression I started off with. So what I have to do is put a minus 2 here. That's the same thing now. X squared plus 6x plus 9 minus 2 is 7. That checks out. And then I can put the minus here, and I can rewrite the 2 as the square root of 2 squared. And now this could be u, and this could be your a. Square root of 2 is a. And this would involve then the secant, because it's a minus. And the u is first, as the u second, is a squared minus u squared. There's the sign. So I'm going to use then a trig substitution involving secant. But this is the main thing here. Also remind you, I will be using this identity here. 1 plus tangent squared of an angle, theta, x, whatever. 1 plus tangent squared. 1 plus tangent squared of the angle theta should equal to secant squared. And I could solve for either one of these. I could solve for tangent squared theta, then equals to secant squared minus 1. I bring this over to the other side. And then I got secant squared of theta minus 1 is tangent squared. So those are my main substitutions and trig identities that we'll use. This is what it looks like. X squared plus 6x plus 7 is this right here. Same thing. And then we said it's the same thing as x plus 3 squared minus the square root of 2 squared. Those are the same. Notice on the triangle that I have here, I have an x plus 3 and the hypotenuse here, a theta here, and a square root of 2 here. And then, of course, this represents this, which is the same thing as this. So if I wanted to find the sine of theta using this triangle, sine of theta is opposite over the hypotenuse. Or if I wanted the cosecant of theta, it's opposite over the adjacent. Opposite hypotenuse, I should say, over the opposite. So sine is opposite over the hypotenuse. Cosecant is just the opposite. Hypotenuse over the opposite. Cotangent is adjacent, in this case square root of 2 over the opposite. Tangent is just the opposite of that. Adjacent or opposite over adjacent. So here, like I said, u is equal to a secant theta. That's the substitution. In this case, this plays the role of u. X plus 3 is equal to the square root of 2 secant theta. And then this right here we got simply by taking the derivative of this right here. Derivative of x plus 3 is dx. Derivative of secant is secant theta, tangent theta, d theta, and of course the square root of 2 comes along for the ride. So you have it there. So now we just make a transformation in terms of theta. So this would be the integral of, and then the dx, it's going to be all of this. So this will be the square root of 2. Then we got secant of theta, tangent of theta, d theta. So all I did there again is I made a substitution for dx. I put it right there on top. Now I need a representation now for x squared plus 6x plus 7. I don't want x's, I just want the variable theta. So here's where I'm going to use the identity that I went over. X plus 3 squared. This is the square root of 2 from right here. X plus 3 is the square root of 2 secant theta. And then here I have a minus, and it's got the square root of 2 here, so this will be a 2 here, because I'm squaring it. And I'm also squaring this right here, from here. X plus 3 is square root of 2 secant theta, so I'm squaring this. This will be a 2. This here squared would be a 2. Take out the 2. Everything is squared there, so the radical's gone. And I'm going to have secant squared theta minus 1. I figured out this 2, and this becomes a 2 when I square it. I get this right there. And from the identity I just went over, this x squared plus 6x, this x squared plus 6x plus 7 then is going to be a 2 from here. And then secant squared theta minus 1, that's tangent squared theta. And then tangent theta and tangent squared, these cancel out. So let me just cancel this out here. And this becomes a 1 here. And this tangent theta can go up, and I can call that cotangent theta. And cotangent theta can be expressed as cosine of theta over sine of theta. And then this is the same thing as secant, that's 1 over cosine. Secant of theta and cosine are reciprocal, so I can replace this by 1 over cosine. And this will go to the bottom. And then cosine of theta here, cosine of theta there, cancel out to 1. Then we can take out the square root of 2 over 2. Square root of 2 over 2. And what I have left here then is 1 over sine. 1 over sine. But that's the same thing. One of your basic identities, that's the same thing as cosecant of theta, d theta. And now we take the integral. Cosecant of theta, d theta. There's one similar to the one for integral of secant. So I'll leave the square root of 2 over 2 on the outside. And the integral of cosecant of theta, d theta, is minus the natural log. I put the minus out here. Minus, and it's the natural log of absolute cosecant of theta plus cotangent of theta, d theta. I'm sorry, plus a constant of integration. I'm using a formula that you should have access to. So the final answer for the integration is minus the square root of 2 over 2, and then natural log of the absolute value of cosecant theta plus cotangent theta plus the constant of integration. And now all I have to do is replace the cosecant and the cotangent with an expression involving x. These are this triangle, and then we'll finish. Because we're always going to give the answer in terms of the original variable. So here's what we have. Still got the minus the square root of 2 over 2. And then it's the natural log of absolute. So cosecant of theta right here is the hypotenuse, as dimension x plus 3, over the opposite side. So that's going to be over that. And then the cotangent is the adjacent side, which is the square root of 2 over the opposite. And that's going to be also over the square root of x squared plus 6x. So I'm just going to put one denominator here. This will be the square root of x squared plus 6x plus 7. And then for the cosecant, it was the hypotenuse, which is x plus 3, over the opposite side. Okay. And for the cotangent, it was the adjacent side, which is square root of 2, so that's why I can put it over the same denominator. This also will be the square root of 2 over the same denominator. So instead of writing two expressions, I have one expression, x plus 3, inside the natural log, x plus 3 plus the square root of 2, over the square root of x squared plus 6x. So it's x plus 3 plus the square root of 2 over the square root of x squared plus 6x plus 7 plus the constant of integration. And that's the final answer again. Minus the square root of 2 over 2 natural log of the absolute value of x plus 3 plus the square root of 2 over the square root of x squared plus 6x plus 7. Thanks for watching. We'll see you next time.